Ocean Observing System. My name is Albert Fisher. I'm the director of the Global Ocean Observing System Project Office, which is based at the Intergovernmental Oceanographic Commission of UNESCO in Paris. And I'll be acting as a master of ceremonies tonight. During the next hour, we'll start with an approximately 30-minute presentation from Eric Lindstrom on work towards a deep ocean observing strategy. And after the slide presentation, we'll conduct a question and answer session by chat, where I'll be moderating the questions that you type in the chat window and ask the questions verbally to Eric. And I'll try to select questions that are representative of sort of community concerns. And of course, we'll try to attempt to answer as many questions as time permits. I should let you know that this session is being recorded, and a link will be posted on the Goose web page. We plan to conduct these webinars every month, and thank you for joining us. So let me introduce our presenter this month. He's Eric Lindstrom. Eric Lindstrom is the Physical Oceanography Program Scientist at NASA headquarters in Washington, D.C. He's program scientist for a number of satellite missions, QuickSat, JASON, JASON2 and 3, SWAT, and Aquarius, and he's the leader of the Earth Science Division Climate Focus Area. His scientific interests include the circulation of the ocean and air-sea exchange processes, and he has extensive experience in both seagoing oceanography and remote sensing. He's now serving as co-chair of the International Global Ocean Observing System Steering Committee and is co-chair of the U.S. Interagency Ocean Observations Committee. So Eric, I'd like to hand it over to you.
Thank you very much, Albert. Happy vernal equinox, Goose World. I hope you're having a great day out there, or night. Today I'm going to talk to you about the deep ocean, and I'm going to talk about coordination of deep ocean observing. This is the main role of the Global Ocean Observing System, to coordinate the activities, the human energy, the national energy, the observing energy that we can bring to ocean affairs. This endeavor started just about 3 years ago with a workshop in Paris on the deep ocean in conjunction with an ocean observation panel for climate meeting. The idea was to help coordinate deep ocean observations by using the newly developed framework for ocean observations that came out of Ocean Obs '09, a large ocean conference that happened in September 2009. And it put forward best practices and ways of organizing our community to better observe the ocean. So we set out with the ambition of trying to expand GOOS beyond observations in the upper 2 kilometers of the ocean. That's the area that's observed by Argo profiling floats and many ship measurements, and move into the deep ocean with a cross-disciplinary suite of observations. So we put together a team of across the disciplines. You can see their names here, a first-class team of ocean scientists to help guide us through developing a strategy to bring the community together. I go back to first to why we want to observe the deep ocean. Over 100 years ago, Fridtjof Nansen, a early ocean explorer, said that I fear that 50 years hence our temperature observations of the ocean today will not be of much value as they are not sufficiently accurate. This is so much the more to be regretted, as not only secular changes in the circulation of the sea, but possible secular variations in the temperature of the atmosphere or the surface of the Earth can probably be most easily demonstrated by variations of the mean temperature of the ocean. And it's with that kind of forethought that we would like to be better observing the deep ocean and understanding how heat and carbon dioxide are affecting the deep ocean and how life might be changing in the deep ocean. There is evidence for changes in the heat content of the abyssal ocean as articulated by Perky and Johnson in 2010, that you can see the invasion of heat into the Southern Ocean, into the western boundary currents of the deep ocean. And that this is not an insignificant amount of heat considering its contribution to the overall heat balance of the Earth and to global sea level rise. Likewise, the invasion of anthropogenic carbon into the deep ocean can change the saturation state very quickly into a state that's difficult for microbial life to survive, and we can see the changes in the aragonite saturation depth occurring over the last decades. Also, we've only begun to scratch the surface of understanding life in the deep ocean. Over 180 new species, 25 new genera, 2 new families have been described from deep water chemosynthetic ecosystems since 2002. So just in the last decade, all these miraculous life forms are being described, and we have yet to get a baseline from which we can observe change in such systems. So our idea is to develop out of the scientific community a strategy for addressing the societal challenge, which is observing the deep ocean and understanding its change and impact on the planet. Deep ocean observation is a big scientific and technology challenge, which addresses these societal issues of climate change adaptation, ecosystem conservation, and sustainable resource management. So our idea is to begin to communicate the need for deep ocean observation and infrastructure to our global set of stakeholders, the science communities, the funding agencies, industry, and the non-governmental organizations. Taking the guidance from Ocean Obs 09, we need to highlight the need for disciplinary breadth in our move forward into observing the deep ocean, encompassing physics and climate, biogeochemistry, biodiversity and ecosystems, and the geophysics, and really bring forth the interdisciplinary nature, including economics and sociology and their impacts. We'd like to, and we need to, use innovative observation technologies and also take maximum advantage of existing observing networks and build upon them. So our plan is to formulate a global strategy for deep ocean from component elements. That's what GOOS does, is we don't make the observations, we help others who make the observations, make them better or more numerous or better coordinated. So there are already existing efforts in called ocean sites for moorings. There are cabled observatories from many countries. The Southern Ocean Observing System is organizing, and so on. So bring together the existing things and add a grander level of coordination and try and expand the system. What we need to do is develop a common statement of requirements and initial strategy for sustained deep ocean observations that consider all the essential ocean variables. You'll hear more about that as the talk progresses, across all regions and technologies, so as to extract whatever we can that's high priority and feasible actions here within the next 5 to 10 years, and try and make some immediate progress so that others can build upon our success in the decades to come, and really live the vision of Fridtjof Nansen to collect a long time series of the deep ocean. Our approach through GOOS is to catalyze the coordination among existing efforts and to use the framework for ocean observing as our strategic guide. You can Google the framework for ocean observing and find the document that describes that, and that is the strategic guide for GOOS going forward. I want to now really talk a few minutes about the capabilities that exist for sustained observing in the deep ocean. We have a ship-based repeat hydrography program internationally that's a platform for observation of many variables. There's also a sparse array of moored time series, some of them very long. Also, a small group internationally of cabled observatories that are able to provide high bandwidth to the deep sea through links to shore. And then we're in an era of rapid technology development, and the potential exists for Argo profiling floats to reach the deep ocean, for deep gliders to be developed, for water sampling on moorings, and new tracers such as Argon 39. So let me go into that just a little bit with some of the pictures here to give you an idea of what already exists and what goes on. As a follow-on from the World Ocean Circulation Experiment in the 1990s, many of the hydrographic lines that extend measurements from the surface to bottom were intended to be repeated on a semi-regular basis every 5 to 10 years. And this map shows the intended decadal survey and countries involved in repeating various of these lines. Now, those are platforms potentially available to expand the measurements into new variables. If we can add new sensors or capabilities onto ships and keep them going along these lines, we get a regular time series, albeit with snapshots on a decadal scale. But this is really helps us trace the evolution of change in the deep ocean, and it's the main data set that we have indicating change now. Our models are of the deep ocean, and our ability to analyze the historical data set are also improving very rapidly, so that the abyssal thermal changes that I mentioned earlier have been looked at in various depth ranges and geographically. These diagrams on the bottom show the heat content change and over from 2,000 meters to the bottom and from the deep ocean in 3,600 meters to the bottom, and show the the warming in the Southern Ocean and the western boundary of the Atlantic Basin, which is well ventilated from the north and the south. So these sorts of changes, these sorts of data are analysis of the historical data set that comes from the repeat hydrographic lines and single lines that contribute into the World Ocean Atlas. New technologies being developed here, the Argo floats, which are more than 3,000 in the ocean, profiling temperature and salinity to between 2,000 meters in the surface. There are now a number of prototypes that will profile to 4,000 meters. This is just one example from Scripps Institute of Oceanography, the Solo float, but there are others in France and Japan, the Deep Ninja, and so on, that are in prototypes and successfully developing to be able to be deployed in numbers in coming years to give us temperature, salinity, oxygen, and perhaps other parameters down into the deep ocean. The ability to trace the ventilation of the ocean is now available through Argon 39 as a tracer. It fills in the tracer timescales between the chlorofluorocarbons that are man-made into the atmosphere and C14. Argon 39 is a radiometric produced in the atmosphere from the solar radiation, and so it has a half-life of 269 years, which makes it ideal for tracing the deep ocean circulation. In 2012, a group of biologists met in Friday Harbor and assessed the impacts of climate change on deep sea habitats, and that's a fruitful area of observing to really lay out the habitats and ecosystems of the deep sea and try and understand how future environmental changes in the deep sea floor will impact these ecosystems and their diversity. We are well aware now that there is a great biological diversity in the deep sea and that it's not a homogeneous system, but has many, many transitions in species across the abyssal ocean floor. So let me move on to trying to develop a deep ocean observing strategy via this framework for ocean observing. We use the framework structure, which I'll explain in a minute, to coordinate our writing team activities and develop a draft strategy, which is available on the website at the bottom of the slides. And it uses ideas like readiness levels to assess the fitness for purpose as relates to the central ocean variables and associated observations and data products and networks for observation. It looks to the community for all the existing panels, experts, and implementation teams that make the observations and to bring them together to facilitate the conversation related to requirements, how to observe, and the data products that are needed going forward. The iconic diagram of the framework for ocean observing is a system of observations. Their deployment and maintenance is the system in purple here, and that it's driven by science and society with issues that cause us to set requirements and seek to determine what to measure And we'd like to transform those requirements into a suite of essential ocean variables that the networks would observe, and that we would then reassemble the data along the lines of essential ocean variables, produce products and services that then impact the issues that drove us to set the requirements in the first place. So the whole system together is about coordinating these networks and coordinating the requirements that go in and the products that come out. And this is the challenge that GOOS has taken on in the coming decade. So if we look at some of the drivers for deep ocean observing, we have the Framework Convention on Climate Change, the Biodiversity Convention, and the Law of the Sea, which relates to the deep sea mining. We have an enormous number of scientific challenges from climate, understanding heat and freshwater transports, the understanding mass transports, closing the Earth's energy budget, the freshwater balance on the planet, understanding global and regional sea level to which the deep sea contributes, and the role of the deep sea in mixing and carbon dioxide and fluxes of heat and salt. The biogeochemistry community and carbon community, they're very interested in the fate of the anthropogenic carbon load and determining the strength of ocean ventilation, how to assess the sources and sinks of potential greenhouse gases from the ocean. And then the biodiversity and ecosystem community is driving us towards more exploration and pure curiosity-driven observation to determine what is in the deep ocean and try and predict future biological responses to the forcing mentioned above, and really understand the functioning of deep sea ecosystems, which are so radically different from the ecosystems we see on our day-to-day basis. So we definitely need to bring all these communities together and all these challenges together to make up a sizable community that can speak with one voice through our governments and to the international conventions. So the challenge that we set out as the science team was to draft a set of essential ocean variables and the observing systems that could take them on their way. For each of the three discipline areas, they came up with essential variables that needed to be part of a sustained observing system. Those in green here are those that are mature and being observed today, and maybe not globally, but in many respects. Those in yellow are slightly less mature, and those that are in red are more in the concept phase and need more R&D to get them moved into a global observing system. You can take each of those essential ocean variables and then map them onto the observing capabilities we have, the ship-based moorings, deep Argo, gliders, submersibles, cable observatories, habitat observatories, and so on down the list of things. And so we've done that for each of the variables, and it starts to give us a way to communicate with each of the teams that between the science teams that are really interested in a particular variable and the operators of various observing networks. The same can be done for the carbon and biogeochemistry essential ocean variables, and for the biology. Biology is perhaps the most complex and the least mature in developing essential ocean variables, but that is going on very robustly, and there's a lot of conversations and workshops going on about developing the essential variables for ecosystems and biodiversity and how to observe them on various platforms. So that is a very rich area for science engagement. So besides all of these central ocean variables and how they map into the observations, we have the third leg of the framework for ocean observing, the data and information that we have to assemble out of all the observations and figure out a way to both assemble, deliver, disseminate, quality control, archive, and produce higher level products out of these that meet the needs of the scientific community and our funding agents and agencies and nations. So there is in our consultative draft for the observing strategy, all these components are described in draft form. So the timeline for the deep ocean observing strategy begins back really in 2011 with the workshop and our work over the last couple of years to bring scientists to the table to articulate the strategy. Here we are in 2014, and we're in the process of having GOOS agree to a deep ocean observing strategy as a project of GOOS and with a limited lifetime and very specific objectives. I'll describe that structure in a moment. We're beginning to roll out the idea of the deep ocean observing strategy to the community with this webinar, and with we had a very great sessions at the Ocean Sciences meeting in Honolulu last month. We're aiming to have an impact on the world of ocean observing, certainly by OceanObs 2019 in Venice in September. A very specific date, another meeting of the scientific community to make our 10-year assessment of where we are with the observing system. We started there in 2009 with the nugget of an idea to move forward with some deep project, and I would like us as a community to be able to really show the change in the deep ocean observing system over the 10-year period from 2009 to 2019. But we're not developing a deep ocean observing system in isolation. It's part of a global ocean observing system. So this is a strategy to expand GOOS into the deep ocean. That's what it truly is. It's a project over the next 5 to 7 years to add a dimension to GOOS that is sorely lacking at the moment. So the idea for the governance of, say, we'll call it Deep Ocean Observing Strategy 2020, is a project under the GOOS Steering Committee that would have its own steering committee that could spin off task teams that are yet to be determined, that it would also have some resource forum for the agency representatives and the funders, and that and it would also be staffed by an ongoing staff over the next 5 to 7 years, and that they would have an executive that the chairs of the steering committee and the resource forum and the staff to coordinate activities over the coming time. So our measures of success to date and how they ramp up between June of 2011 and June of 2013, we really developed the strategy report that's on the web at the GOOS website. And those materials are available to you. We've had some small successes, but real successes. The Ocean Sites Network of Moorings sought to have deep temperature salinity probes put at the bottom of all the deep moorings in the ocean, and each of those measurements is matched by a sensor provided by oceanographic institutions around the world. And on the basis of this larger project in GOOS, Seabird Electronics is conducting the calibration of all those sensors pro bono as its contribution to deep ocean observing strategy. So there are benefits, tangible benefits to coordinating on this global scale. This year we're identifying the oversight and coordination bodies, the steering committee, follow-on activities, what we can do to immediately begin executing more coordination and activities. We certainly will have a deep ocean workshop in 2015, and we will also be rolling out this concept to the higher level groups, the conventions and scientific bodies around the world, to alert them to the opportunity to coordinate deep ocean observations. So in the next 2 years, we'll develop the program with the steering committee. Scientists will be conducting design studies based on models, the existing observing system, and we'll be trying to incorporate ourselves into the global climate observing system, the CLIVAR of the World Climate Research Program, and all the programs that will be folded into Future Earth. So in 5 years, I hope to say that we definitely have pilot programs underway, and that in that same time period, 2019, that OceanObs 19 will be organized, and they'll be reporting on the great successes of observing the deep ocean that have come out of GOOS coordination. I will end talking about the deep ocean there, and let you know about our April event of the which will be about the Tropical Pacific Observing System, a system for research and forecasting. A group is organizing to evolve the present Tropical Pacific Observing System into a new system in the 2020 period. And the speakers will be Toshio Suga and Katie Hill, and it's on Wednesday the 23rd at 1000 GMT. So thank you very much for listening, and I will rest my voice for a moment and turn it back to Albert and let you ask questions.
Thank you very much, Eric. And I do want to point out that web address where you can download the draft strategy for comment, which is ioc-goose.org/deepocean, all one word. So I would like to ask the participants. Thank you. First of all, thank you very much. I see that we really do have participants from all around the world, from daytime and nighttime sides of the world, including I see a couple of participants from India, where it is I think about 2 or 3 in the morning. So please enter your questions into the chat window. We're asking for questions on why we observe the deep ocean, how we can do it, how to sell it to observing funders and scientists, particularly on the project. So let me expand the chat window so I can see everyone's questions. I think that's done it for everyone, in fact. So I see a lot of questions being typed. We do have one question that's on there right now. It's quite a scientific question. It's from MM Ali. What is the role of orbital velocities in the ocean heat content distribution? So I don't know, Eric, if you want to try to answer that question while other questions are coming in.
Well, I can take a stab at trying to understand the question first. Orbital velocities, I'm thinking maybe there's definitely a role of the rotation of the Earth in the deep ocean circulation. Much like the surface circulation, there are western boundary currents, deep western boundary currents in the western sides of the ocean basins that uh, ventilate polar water towards the equatorial region. So that is, if I were to, that's one interpretation of what was meant by a question about orbital velocity.
Okay. So we have quite a few questions here. Let me try to take them in a certain order. Actually, let me answer Roger Lucas's question myself. He asks, why doesn't the shipboard repeat hydrography include the time series stations? That's just a matter of definition. Certainly, the time series stations are included in the Ocean Sites network, which is a network of either moored or other ways of taking time series stations. The map that Eric showed is from the network called GoShip, which is really about basin-wide, coast-to-coast repeat hydrography to try to capture transports. And so they have a rather strict definition of what is a GoShip line, which is a basin, cross basin line. So let me go back. Jonas Rupp asks a
So
question, Eric.
could I
Yeah, please
break
go.
in there? And I think that it would be the cabled observatories and long time series, as Roger Lucas is involved in, are foundational in our observations of the deep ocean. And I would like to invite Roger and his colleagues to present in a future webinar about cabled observatories and what's possible at a place like the Aloha Cabled Observatory.
Okay, thanks, Eric. Um, there's a question from Jonas Rupp, which is, what are the prospects for observations to be translated into three-dimensional modeling to simplify things for decision makers? And I guess it's not just modeling, but really to synthesize information to help decision makers make decisions about managing the deep oceans.
Well, this is a central capability that we have today that was only embryonic a few decades ago, the ability to collect observations and then interpolate between them using model ocean to extend a model in time. So we have global state estimates, as we call them, of the ocean that are fully populated grids of the ocean that are constrained by the model, the observations that we have. So these sorts of products would be available if we had more observations in the deep ocean. At the moment, most ocean models are still under constrained by observations. We don't have observations of all the eddies and so on that are so important to the dynamics of the ocean. So we'll need a lot more observations of the deep ocean to make good estimates from models of the state of the deep ocean.
So, Eric, let me ask a related question that's posed by Boris Kelly-Guerin, which is, given the sparsity of data in the deep ocean, how confident can we be with the models, and particularly, how confident can we be in using the models to help design the observing networks and helping designing strategies?
I would say that we have to use everything that is in our bag of tricks, but I think that most observational oceanographers have are quite skeptical of model results, particularly of the deep ocean, in terms of designing our observing system. So like any an economic analysis, cost-benefit analysis or something like that. It's a data point for you to use, but you would use a whole array of your knowledge and instincts in designing the system. We get better with time, but the models by themselves cannot be our only guidance.
So there's a question about integration or basically expanding observing systems to extend into the deep ocean. It's a little bit, I think it's also linked to a question about integration. What do you think, Eric, are the prospects for really using the same platforms to integrate across measurements of both of physical, chemical, and biological variables?
So a lot of progress is being made on this, that the same, take Argo as a platform that biologists are tricking out Argo floats to be bio-Argo, and chemists are making chemical Argo floats, and so on. And that seems to me to be simply a path towards integrated Argo floats. One of the great limitations of such platforms is battery life and energy. And so, we need to make inroads not just in sensors, but in energy for Argo floats. And there are possibilities there, phase change materials that allow you to use the vertical thermal gradients in the ocean to drive the floats, and so on. So all of these things are very much healthy research activities going on at the moment. I feel very optimistic that by the end of the decade we'll have some very sophisticated profilers. Okay.
But meanwhile, I'll try to recall some of the questions that I saw. There was a question from Cesar Toro. There's obviously a lot of interest in the seabed, growing interest in the seabed and industrial uses of the seabed. Have there been any thought to trying to connect to the International Seabed Authority that governs mining on the seabed in terms of developing this deep ocean observing strategy?
Yes, and I think it comes in many dimensions. The companies and countries interested in seabed mining are responsibly interested in understanding the environment and what environmental damage that seabed mining could cause. So there's an opportunity for scientists partnering with the exploration of the deep ocean for mining purposes to go there. I'm already involved with, there is a broad array of submarine cables across the ocean, and their potential observatories themselves with repeaters about every 50 kilometers along their length that could have sensors installed in them, and that's a robust discussion going on about the possibility of instrumenting cables. So the connections with industry are quite possible, but there are also big tensions between conservation organizations and industry so GOOS has to have this discussion across quite a broad political spectrum.
There's a couple of related questions from Craig Dunn and Roger Lucas about the accuracy required to measure the deep oceans and measure the slow changes in the deep ocean. What are the plans to work on that calibration and accuracy, and how would that particularly how could that be done from autonomous platforms which aren't necessarily recovered?
Yeah. Good questions. Questions that I do not fully have the answers to. we're beginning, I think, with the Ocean Sites program to collect some time series with sensors that can be brought back, and we can understand what kind of drifts there are in deep temperature insulating sensors, what sort of accuracies are available. More work needs to be done on that. The traditional way, of course, is to use Lagrangian platforms or ships to test out strategies and sensors and getting them back, recalibrating. But I honestly don't know of all the developments that are going on there. I think Roger Lucas would be in much better position than me at NASA headquarters to know about those developments, and I honestly think it would be great to have that discussion as part of a future webinar, because it impacts way more than just the deep ocean. It's a goose-wide issue of so many new sensors coming on board, and are they accurate enough? When do we start using them in large numbers, and what sort of systems checks and balances do we need to have in place to monitor, to make sure that data is of the highest quality?
So Eric, there's a question from Tony Coslow, which is, again, a little bit scientific, particularly for your experience, but perhaps you can tell us how it's being addressed in the Deep Ocean Observing Strategy, which is about, in fact, and it comes back again to the definition of what is the deep ocean. It's the question is that there's the Mesopelagic between 200 meters and 1,000 meters. Micronectin is a major gap in deep ocean biological observations. There's evidence of major changes occurring in this realm due to declining oxygen, but there's a lack of global observations. So is that a question that has come up amongst the biologists participating in the development of the strategy? And, yeah.
Yes, absolutely. It has come up, and that is, one of the a driving question from the biologists who say, well, you can't define the deep ocean as just below 2,000 meters because it's really the dark ocean that you should be concerned with, and from a few hundred meters on down, and that's a realm that we do need more observations. And I feel like I'm totally open to that for the biological variables. That maybe that's where the emphasis needs to be, and we aren't just developing sensors for below 2 kilometers. It's for the whole water column, maybe specialized sensors below the photic zone. So that's the idea of GOOS is not to restrict people by definitions, but to try and air out all of these concerns and help people get their own niche more visible to all the other people making ocean observations, so that everybody can help each other out.
And maybe one final question is that, at least from a physical point of view, and perhaps from a biochemical point of view as well, the changes in the deep ocean are fairly slow. And so how do we sustain a deep ocean observing system for the decades it'll take to really understand the variability and the trends? And then a related question is, then what are the plans to sell this deep ocean observing system to the funding community?
Yeah, so that's a good question. I kind of believe that it's almost too much of a question. We take on observations, one observation at a time, and the system evolves. Those are the most valuable time series are these long time series that really help us, and they have scientist communities that surround them and nurture them. And we're looking to grow more communities that want to make long-term commitments to the measuring in the deep ocean. And we need to learn from all the communities that have done this successfully how new communities can go forward and make their argument. So GOOS is about having that conversation, learning from the people who've been successful and passing it on to others who have ambition to be successful. I think that it may vary from one country to the next, how these things are funded, who supports it, why they support it. We have to be open to all this variability. And it's probably, from what I've learned the last few years, it's definitely not true that the deep ocean is a place of slow change and little variability. It can be a place of great variability and rapid change, and we need to be open to that as well.
And that's something a deep ocean observing system might let us discover, because there is real lack of observation. All right, I want to thank you very much, Eric, for giving that talk and for really kicking off the more public aspect of the GOOS webinar series, where we've reached out to a large number of people. Thank everyone in the audience for participating despite and sticking through the technical difficulties. Thank you very much. And I'll just end with a reminder that we will have the next GOOS webinar 1 month from now on Wednesday, 23rd of April at 10 o'clock GMT. And you'll receive a reminder that tells you what your local time will be. And the topic of that is a future sustained tropical Pacific ocean observing system for research and forecasting. And the talk will be given by Toshio Suga and Katie Hill. So again, thank you very much. Thank you, Eric. And thank you to everyone who's participated.
Thank you. Happy spring.